Our last lesson of 7.2, and it's been a challenging section. I bet you're shaking your head and agreeing with me. Example 1 was probably a shock to all of our systems, and learning how to pull a GCF out and leaving behind what remains after we pull that GCF out of a polynomial is challenging, but we're building on that, and we can't do example 5 if we don't know how to do example 1. Okay, now factoring with opposites, this is an interesting section. I've already touched on this earlier in some other examples. We are going to factor by grouping. That is always my default whenever there are 4 terms. I always factor by grouping. That's what I attempt to do, and sometimes the only thing I can do is pull out a GCF and I see that there's no common binomial, then I just stop. But that's where I go with this. I factor by grouping. So sometimes you're going to have numbers where the signs are a little bit funky, okay? And I want to show you in letter A what I'm talking about. So we're going to follow our game plan like we did in example 4. We want to pull out a GCF. The GCF of 3x cubed and 15x squared would be 3x squared. And then what's left will be 3x squared times x is 3x cubed, and 3x squared times 5 is 15x squared. So looks good. Now we get here and it looks like the only GCF I can pull out is a 2, and that's going to leave me with 5 minus x. Okay, well, we have a problem because x minus 5 and 5 minus x are not the same thing. And there's no such thing as commutative of subtraction. There just isn't. Let me explain to you down here in this open space. For example, if you did 7 minus 3, that's 4. But what's 3, sorry about that. What's 3 minus 7? Negative 4. There's no such thing as commutative property of subtraction. You can't flip numbers around the subtraction sign because of this exact problem. You will ruin and mess up the sign. So I can't just flip 5 minus x and go, hey, I'm going to make it x minus 5. You can't do that because it's not appropriate. What you can do is what we call factoring with opposites. And really what we need here in this quantity, we need x to be positive and 5 to be negative. Okay, think back with me. Kind of dial back deep recesses of your brain. What number, the only integer, that all it does when I multiply with it or divide by it, all it does not change the number, all it does is change the sign. What is that number? And if you are screaming at your monitor right now, -1, you are exactly right. So what we're going to do is we're going to actually undistribute or take out of this second quantity right here. We're going to take out a -1 because we want to be deliberate and change the signs of that 5 and that negative x so that they become -5 and positive x, which is what we have in that first quantity. Now when I take the -1 out, remember what I just said, positive 5 becomes -5, negative x becomes positive x. Now what happens right here? Well, you just multiply the 2 and the -1 together, and you'll have 3x squared times the quantity x minus 5 minus 2 times x minus 5. Now do we have a common binomial? Yes, Mrs. Thompson, we do. And here we go, and we're going to factor that out, and then we're going to put what's left in the other quantity. Okay? So that's a little funky, I know, but sometimes that happens, that situation happens, and we have to recognize how to fix it, that it is fixable, first of all, and how to do it. So let me do B with you. Here's B. Let's see, we got 15x squared minus 10x cubed. I think I'm going to take out a 5x squared. That's going to leave me with 3 and 2x. Okay. So I got 3 minus 2x in that second quantity. And then let's look at 8x and 12. Let's pull out a positive 4, and that's going to leave me with 2x minus 3. Okay, same exact stinking problem, okay? I've got 3 minus 2x, 2x minus 3. They're not the same. They're just not the same. If I pull out a negative 1 out of this quantity, it's going to make positive 3, negative 3, and it's going to make negative 2x, positive 2x, which is exactly what I need, because the other quantity has a positive 2x and a negative 3. So if I do that, take out a negative 1, I'm going to put that negative 1 out in front with the 5x squared, making it negative 5x squared, and then I'm able to change my signs because I took that negative out. And now, look, I got a common binomial. Woohoo! I'm able to factor this. I can now. I was stuck before, and now I'm unstuck. And I can finish the problem, and here's my answer. Okay? So I'm going to leave the last one for you. That one, I don't think it's terribly hard. It's not harder than the other two ahead of it. But if you can do that one, show me your answer. And just give it a shot. See what you can do with it. Doesn't hurt to try. Bring your questions to class tomorrow.